In this next section of 1.3, we need to learn how to do something called simplifying complex fractions or simplifying rational expressions. So rational, this word where it says simplify the following rational expressions, rational is just another word for the word fraction. Okay, so something that's a fraction can be written as a ratio, right? And something that's a ratio can be written as a fraction. So when we're simplifying rational expressions, it means we're dealing with something with fractions. So in these first two, it looks like we're going to take this fraction and divide it by this fraction, okay? Well, that seems like a pretty complicated thing, but there's an easy way that you can kind of go through this that'll help you out. So what I would do is I would take each of the sections of the fraction, so the numerator, the denominator, all the pieces, and I would factor them like we did in the other section. So this 4y squared minus 9, hopefully you recognize that as our difference of two squares pattern. So this is going to be 2y plus 3 and 2y minus 3, okay? The bottom of this one, if we factor that out, 2 times negative 18 is negative 36, and I need things that add up to negative 36 and give me 9, so it's going to be 12 and negative 3. And remember, we have to divide out by this coefficient, so divide by the 2. So this will give me 6. This doesn't divide out, so this factors to y plus 6 and 2y minus 3. Okay, so this one factors to that using our bottoms up method. Y squared plus 5y minus 6 should be something that you know how to do at this point in your head. So things that multiply to negative 6 that add up to 5, that's going to be positive 6 and negative 1. So this is y plus 6 and y minus 1. And then we'll do the same thing in this one over here. I'm going to go ahead and use my method. So we'll go negative 6, and I'm doing that because it has a coefficient more than 1. So things that multiply to negative 6 and add up to 1. Well, things that multiply to negative 6 and add up to 1 are going to be 3 and negative 2. Divide by the 2 from here. This gives me negative 1, and that doesn't divide. So the numerator of this piece is 2y plus 3 and y minus 1. So now that I've got everything factored, I'm going to keep in mind the problem that I have division, right? So I have a fraction divided by another fraction, okay? And whenever you were dividing fractions by fractions a long, long time ago, somebody told you about something called keep, change, flip. So we're going to keep the first fraction, change this to multiplication, and flip the back one. And I'm going to do that with these factors, okay? So I'm going to keep the first one like it was, so 2y plus 3, 2y minus 3, over y plus 6 and 2y minus 3. And then I'm going to change the division sign to multiplication, and I'm going to flip the back one over. So keep, change, flip. And 2y plus 3, y minus 1. Okay, now the cool thing about multiplication is that if something is multiplied and you have it on the top and you have it on the denominator, it doesn't matter which fraction it's in, it'll cancel out. So this 2y minus 3 right here will cancel with the 2y minus 3 down here. The 2y plus 3 right here will cancel with the 2y plus 3 down here. And that only happens with multiplication. Y plus 6 cancels with y plus 6. And y minus 1 cancels with y minus 1. But if everything cancels out, I feel like your original thought would be, oh, that's 0, I'm not left with anything. But think about what happens if you have a fraction like this. If we had 2 divided by 2, those 2's cancel out and leave us with 1. So whenever everything cancels out in fractions, it leaves you with 1. So make sure you're aware of that and you don't consider this to be 0. That's a pretty common mistake. Taking a look at B and A are actually the same type of problem. It's just that B is written so that you have a fraction within a fraction. But this fraction bar right here just means divide. So we're going to keep the first one, change the division to multiplication, keep, change, flip. And flip this guy over. So this is x squared plus 2x plus 1 over x. Okay? Well, the x cubed can't be factored. X plus 1 can't be factored. X squared plus 2x plus 1 is actually x plus 1 squared, right? If you factor that out, you get x plus 1 times x plus 1, which is x plus 1 squared. So now I can cancel things out. So this x plus 1 cancels with one of the x plus 1s up here, so I'm going to cancel out that squared because I only have one left. And x cubed and x, well, one of these x's will cancel with one of those, so that'll just leave me with x squared. So I have nothing left in the denominator, but here I have x squared, and here I have x plus 1. So you're more than welcome to leave the answer like this. On some of the multiple choice questions, they might have distributed the x squared in, so they might call this x cubed plus x squared. So either of those two answers would be acceptable. They're really the same thing. But the big point is keep, change, flip. Okay, so whenever you have division like this or like this, you're going to keep, change, flip. All right, looking at problem C isn't division, it's actually addition. And you're going to work addition and subtraction problems exactly the same way. What you need to do is get common denominators so that you can put the two fractions together. So this denominator has an x plus 5. This denominator has an x minus 3. So this one is missing the x minus 3, okay? And whatever you do to the top of the fraction, you also have to do to the bottom. So if we're going to multiply the bottom by x minus 3 to get a common denominator, I also have to do that to the top. Okay? The same thing over here. This one's missing the x plus 5. So if I do that to the denominator, I also have to do that to the top. All right? And then this 1 gets multiplied times the x minus 3. So the top of this one is now x minus 3. And do not FOIL the bottoms together. I'll tell you, 99% of the time you are not going to FOIL the bottoms out, so just leave them alone. Plus 2 times x is 2x, 2 times 5 is 10. And again, leave the bottom alone, don't FOIL it out. Okay, so now I have common denominators, so I can put these two fractions together. And I'm putting the two fractions together by adding. So I'm going to add the top of this fraction to the top of this fraction, and that just means I need to combine like terms. So x plus 2x is 3x, and negative 3 plus 10 is 7. And that's all over x minus 3, x plus 5. Okay? Looking at the top doesn't factor, so it's not going to cancel with anything in the denominator, so I'm done. Okay? So we've combined the fractions and simplified it and just made it into one fraction. Okay? Letter D is probably my favorite kind of problem, and it is the problem that you're going to see the most in calculus. So looking at this problem, the first thing that I notice is that I have two fractions within my fraction that are separated by a minus sign. Okay? And if it's minus or addition, either one, subtraction or addition, it doesn't matter. You still can't use the keep, change, flip method that we used up here. Keep, change, flip only works with division, right? Only works with division. And do you notice that C and D are also different because this was two fractions added together, but this is two fractions added together within the context of another fraction. So we're going to do something a little bit different for this type of problem to make your life a little bit easier. This guy right here, hopefully you'll notice these negative exponents, and we can rewrite that pretty quickly. We're going to rewrite the negative exponents normal as positive exponents because we talked in the last section that you couldn't leave negative exponents in your problem. So this x to the negative 2 is really 1 over x squared. And this y to the negative 2 is really 1 over y squared, right? That's your properties of exponents. Okay, so then what I'm going to suggest that you do for these problems is actually multiply the top, the entire top, and the entire bottom by the same common denominator. But we're looking for something that's going to cancel out the denominators, okay? So one term that will cancel out all of the denominators at once, okay? So if I look at this one, I notice I have 1y, okay? If I look at this one, I notice I have y squared. My largest exponent between the two is the squared. So I'm going to multiply the top and the bottom by the y squared. Okay. I also notice that I have an x on this one and an x squared on this one. So the largest the largest exponent is the squared. So I'm going to multiply by y squared and by x squared. Okay, so whatever the greatest common denominator is, I know that's kind of not the norm for what we normally do, but the greatest common denominator, so between the x's, that's the x squared, between the y's, that's the y squared. So we're going to multiply everything on the top by this and everything on the bottom by that same term. Okay, so I'm going to write this out kind of longhand so you can see exactly what's happening. So I'm going to have, and I'm going to call this x squared, y squared, just because I like to do things alphabetically. So we'll call this x squared, y squared times the first fraction minus x squared y squared times the second fraction. Okay, we're going to do the same thing on the bottom. X squared y squared times the first fraction. And then x squared y squared times the second fraction. Okay, so we've just distributed this term that we found our greatest common denominator and multiplied it into all of the different fractions that I had. And this maybe looks like it's harder, but take a look at what's going to happen. If I multiply this fraction by x squared y squared, this y and this y, one of them is going to cancel out. Okay, so this term here turns into x squared y times x. So that's x cubed y. Okay? Okay, so let's take a look at what's going to happen with the second term. If I have x squared y squared times this x in the denominator is going to cancel with one of the x's here. So that leaves me with x times y squared times y, which is xy cubed. And that's the top of our fraction. The bottom turns out even nicer. If I have x squared y squared times 1 over x squared, well, the x squared and the x squared will cancel. So this is just y squared. And the same thing's going to happen over here. I have x squared y squared, and then this y squared, so the y squareds will cancel. That leaves me with x squared. Okay? So now let's see if we can simplify it down any further. If I look at the top, I notice that both of the terms have at least one x and one y. So I'm going to factor those out. So if I factor xy out of this term, that's going to leave me with x squared. And if I factor an xy out of this term, that's going to leave me with y squared over y squared minus x squared. Okay, so do you see that this part of the top and this part of the bottom are almost exactly the same, but the signs are backwards? So this one has a positive x, this one has a positive y, this one has a negative y and a negative x, right? So they're just backwards. So remember, that means if I look at the denominator, I can take -1 out of that, and it just changes the signs around. Sorry, I wrote it wrong. So if I were to distribute the -1 back in, I would be left with this. Well, notice these two are the same. So these are going to cancel, and that leaves me with xy over -1, which is actually just negative xy.